Hi guys, we're looking at Pythagorean theorem today and also the converse of the Pythagorean theorem. We have looked at Pythagorean theorem in the past, but now that we're dealing with our right triangle unit, we're going to spend a little more time on it because there's other versions of the Pythagorean theorem that we can use to help find missing sides. So just as a refresher, we looked at geometric mean last time, which helped to find the different pieces of the lengths in the right triangle. But again, geometric mean was used when we have the altitudes given to us, because the altitudes create that shorter piece and longer piece of your hypotenuse. So we need other ways to find the lengths in right triangles when we don't have that altitude, and maybe we only have two sides. Maybe we only have the short leg and the long leg, or maybe we have one of the legs and your hypotenuse. How can I find the missing leg in that right triangle, or the missing hypotenuse? And that is where your Pythagorean theorem comes into play. Pythagorean theorem works best when you have two sides of a right triangle. So let's make sure we have our right angle in there for this to be a right triangle. Your two legs, like they were with geometric mean, are the A and B. It does not matter which side of the triangle, in all honesty, that you claim to be A or B, but regardless of where you put the A or B, you always have a short leg, which I tend to let A be my shorter side, and you have a long leg, which I tend to let be my B side. And straight across from that 90 degrees is always the hypotenuse. In any kind of right triangle, that is always true. The legs make the 90-degree angle. Straight across from that, opposite the 90, is the hypotenuse side of the triangle. Now, we all have heard the a squared plus b squared equals c squared formula for those right triangles. But let's say you need to find the c. There are some user-friendly steps here that we can follow to get that missing piece. So first thing we need to do is square the legs, which means take them to the power of 2, the exponent. We then need to add those values. And then square root the sum. Now, we are going to be breaking down those square roots. We are not going to be taking them to the decimal. We're going to break them down the same way we've been doing. So for this specific example, again, I usually let the smaller leg be A, the longer leg be B. Across from that 90 is the hypotenuse, and that's what I'm trying to find. So follow the steps. We're going to first square the two numbers. So 10 squared, actually, let's put A first. 8 squared. Which is 64. 10 squared, which is 100. Step 2 says to add them. So that is 64 plus 100, which is 164. And then step 3, square root it. And this is where we are going to break down that square root. So let's see if we can find two numbers that will give us 164. So we're going to break that down. So again, if you're not sure about a number that will divide into 164, use your calculator and start small and work your way up. 164 divided by 2 gives us 82, but I'm going to see if there's a little bit bigger one. 164 divided by 3, it gives us a decimal, so 3 won't work. 164 divided by 4, 4 gives us 41. I'm going to try just a few more. And if not, I'll try the 4. Divide by 5 doesn't work. 164 divide by 6. Still a decimal. So I'm going to go ahead and go with the 4. So I can break this down to a 4 and a 41. Now, 41 will not go farther. 41 is a prime number. But my 4 can go farther to a 2 times 2. And guess what? There's my pair. So that can bring out a single 2. 41 is left over, so it is still inside the radical. So final answer, 2 square root 41. So we have our final result. So just to simplify this formula, so we don't always have to go through this 3-step process. So if I need the hypotenuse, I'm looking at, kind of go backwards. We square rooted 164. Well, where did I get 164 from 64 and 100? Because and how did I get 64 and 100? I squared the A number and B number. So A squared and B squared, that was my 64 and 100, and then I added them together. So we can use that for our formula anytime I need the hypotenuse. Now let's see if we can generate a formula to help us find out one of the legs. And again, the clue here is to find any leg, which again means A or B. The pattern is still the same. So we are still going to square them. Oops, sorry. We are still going to square them. This time, though, we're not going to add them. We are going to subtract. And then I will square root. So to put all of that in a user-friendly formula, if I need A, we're going to do exactly that, kind of go backwards here. We're going to take the square root of, now this is very specific, C squared minus B squared if I'm looking for A. Or if you need maybe your B side, B equals the square root of C squared minus A squared. So it just depends on how are you labeling the triangle. I need specifically the B side this time, so I'm going to use the B equals formula. So we've got our A side, and I have the C because it's always across from 90. Now again, if I didn't have a B there, maybe it was a different letter, maybe an X, then it's your choice. Do you want that to be A or B? Formula is still the same. In this case, our missing side, we're going to square them and subtract. So C goes first. 25 squared minus the other leg squared, in this case 7 squared. And let's see what we have. So first I need 25 squared, which is 625. I'm going to take away 7 squared, which is 49. Which is the square root of 576. Let's break that down. All right, so one thing I know, 576 is divisible by 12. I can go through the same division I did before and see if I can get a little bit bigger number, and I can find 12 here. 12 and 48. Both of these can go farther. 12 can become a 4 and a 3. My 4 can go farther to a 2 and a 2. There's my first pair. Now let's do 48. Can go 6 times 8. 6 and 8 can both go farther. 6 can go into a 2 times 3. There's a pair. 8 can go farther, a 2 times 4. There's another pair. Pair of 2s there. And now 4 can go farther. Oops. 2 times 2. Another pair. We've got lots of pairs going on here, and nothing at the end of these branches is left over, which means 576 is a perfect square. So we had 3 pairs of 2s and 1 pair of 3s. So let's multiply this back together. 2 times 2 is 4. 2 times 3 is 6. So 24 is my final answer. There is my missing side of the triangle. So again, whether we needed the A side or the B side, we still square them both, and then C squared minus whichever side they give you squared. Now, one thing we're going to talk about with Pythagorean theorem, you also get the converse of that. The Pythagorean theorem says that if a triangle is a right triangle, then A squared plus B squared equals C squared. Well, the reverse of that is true, because remember, converse means you can switch them. So that means if A squared plus B squared is equal to C squared. So if it's true, if I take the two legs, square them, add them together, it's the same as the hypotenuse squared, then the triangle has to be right. Is a right triangle. And that is what the converse says. Now, you can also use that converse to classify your triangle, to determine if it's supposed to be acute, right, or obtuse. And let's see how that works. Let's look at our 3 variations here. All right, so when our C squared is smaller, less than A squared plus B squared, and again, notice C squared is always first. If C squared is less than A squared plus B squared, then you have an acute triangle. All the angles are less than 90. If it is equal, if the two pieces are equal, then that's when you get the right triangle, because that is when A squared plus B squared equals C squared. But if C squared is bigger, if the hypotenuse is biggest, that is your obtuse triangle. So let's try a quick example. All right, let's say you have the numbers 3, 4, and 6. Remember, C is always the biggest. And I said earlier, I usually let A be my smallest side, which means my A, B, and C. So leave a space for C squared. We're going to have to figure out what symbol we need. And then we're going to add up A squared and B squared. So if my C squared is 6, that is 36. A squared is 3, so 3 squared, which is 9, plus B squared, so 4 squared, which is 16. 9 plus 16 is 25. So 36 is greater than 25, which means this triangle is obtuse. So you have to have C squared first. All right, guys, so I hope you enjoyed learning a little bit about how you can use Pythagorean theorem and its different versions to find the missing side lengths in your triangle, and also how you can use the converse to classify the triangle. So please don't hesitate to reach out to me if you have any questions at all. Bye, guys.